Our examples were on discrete attributes, attributes that took a bunch of possible values, categorical. You can also do decision trees for continuous attributes. So if your attributes are real valued, what the decision tree does is it doesn't split into subsets based on the value, but what it does is it tries to pick a threshold. Right? So it looks at a certain attribute, maybe this attribute is height, and then it will sweep all the possible values of height, right? So, 150 centimeters, 160 centimeters, 170 centimeters, 120 centimeters. For each one of those possible threshold values, it will sort the data into two subsets, one that is smaller than 120 and one that is greater than 120. And then once you've split them, you can compute your the information gain, or the entropy of the subsets, in the same way that we did for discrete attributes. The only thing that you now need to add is you need to add a search over the possible values of a threshold. And again, if you do it naively, it'll be very, very expensive, but if you pick the right data structure, it's not terribly expensive to sweep all possible values of a threshold and find the optimal one. So, and then you're going to recursively do the same thing over all attributes. So maybe in this case, first you decided to pick attribute x1, so you found the first threshold theta1, and that threshold separates the space into two parts. So everything that was smaller, where x1 was smaller than theta1, so that's regions A and B, and everything that was larger than theta1, so that was C, D, and E, right? So that's the corresponding decision tree. You're testing, was the attribute 1 greater than or smaller than theta1? And then you do it recursively, right? So on the left branch, where you're smaller than theta1, now you pick a different attribute, x2, and do a split on that. One interesting thing about continuous variables, real valued attributes, is you can end up using the same attribute more than once in a tree. With categorical attributes, it's impossible, because once you've sorted on the weather, say, on the outlook, everything rainy is already in that subtree. So you cannot split on outlook anymore because they're all rainy already. With real valued attributes, you can split multiple times. So in this case, in the third level, I guess on the second level of the tree, or third, you end up splitting again on x1 with a second threshold, theta4. And you should see that depending on how complicated the distribution of positives and negatives is, you can end up splitting in lots and lots of different ways and using the same attribute over and over and over again in the decision tree.